this is a quick example of how I'm trying to understand quaternion rotation, and this English version. So quaternion can be used to represent 3D rotation in three.js, and I spent a lot of time trying to understand how it's happening, and now I made a very simple demo for showing the results of multiplications in a 3D space. So this is the demo, and first I'm going to hide some of the values. Empty. Now I have hide on all the strips here, and only a simple point is left here. So this is the point of four-dimensional point, the multiplier represented in 3D space, and it's actually what's log. Let's try the log. So the point, the value is 0.8.6, and this is the C direction in this way, in this direction, and this is W, which is invisible in 3D space, but in this demo I'm going to display it in such a column. It's a tube. It's actually a tube in 3.js, and I can enlarge W, and then Z becomes smaller to 0.4, and you see it's closer to the 0 point. And if W is really small, then C would be larger. C would be larger to 0.996994998. Anyway, so this is just a simple point in 4 space, just represented on my screen, and rotation. And rotation can be represented in this way, and well, I'm not very sure about this, but this is a rotation. I'm not sure if it's the correct form. But I see it in some other places. The angle. Sorry, I can't find a very good angle. Oh, maybe there's one. Just this one. So to calculate a 3D rotation, a new vector is constructed. It's actually a four-dimensional constructor with this one in 3D space and this one in the fourth dimension, which is in the W dimension, and to compute to calculate the rotation, it's like a sandwich, like by multiplying this to original point and then multiply to the inverted value of this factor, and okay. So in my demo, I made it in here, yeah. So this is the point, original point. When it's multiplied, it's the first time it multiplied to this one. When they are multiplied, it's turning to here, turning to here. So this is the internal point, and it has a value in w dimension. It's a negative value, so it's in pointing to negative direction. And it's turned to it's applied to the second multiplication is turned to be here. And I'm not very sure, but in one put a plane here, you can see from the demos there's 2 points in the same plane, and the internal point is in here it's not large enough in the y in the z direction, and to view it from the rotation axis, maybe not accurate. Roughly from the point. So very roughly, it's like a rotation. So this may not be very correct. Well, it may not be very accurate, but this is the rotation, and if we don't think about the empty. Why it's not defined? Well, this is weird. Well, this is an accident. Anyway. Well, this is not a very good example here. Since the program, there must be some invisible character here. So it's the other example I'm going to show the how the numbers are repeated multiplied. So this one. So for the most simple case, there's only 1 point, and it only computed once, and the original number is here. It's a number in the plane. This plane, the z value is 0, and it's in x and y. It has values, and it also has 0 value in the w direction. This point. And as it computed once, got another value, maybe. So again, do it again. So the first point, and it calculates the second point, and it just continuing multiply next, which is this point, to the point. Oh, mistake. So next is this point. And P is this point, and it also represents this point. Next calculation. So the first time it's calculated, and it's generating another point here, and the fourth, and the fifth, and more points. So in this case, it's very like rotating. Maybe too many. It's very like rotating. And if we view it from the axis, the C axis, so it's just a rotation. Just a rotation. Just a rotation in this direction. Well, this demo is very special because it uses a multiplier, which is using only 6. Yeah, it is only using 0 and 0 in x and y dimension, and the point itself is using 8 and 0. It has 0 value in here, and also 0 value in w. What if there's some value in c direction? Let's see it from here, from the demo. So the points to 1, and let's add more points, like 2 points. So one more point is added here. One point added here, and we'll get more points. So how is it going to be multiplied to? Well, so where is the next point? So let's change to 2, and it's multiplying, and 3 is multiplying again. But we also notice here for the numbers with so we use this point. So this point is in the it's in the axis, the plane where c is 0, and this point has no value in y dimension, in the w dimension, and this one, it has 2 in the z direction. Now as it's multiplied, it has the c direction value in w direction, and as it can increases, and the result increases again also. So but when we also view it from here, from the axis, it still looks like it's rotating. It's rotating around the axis. So this one is rotating. It's rotating. Meanwhile, since we already set the modular to be 1, the length should be only 1, the multiplier. So the original factor should keep the same distance to the original point. So that this point, as it multiplies, it will also still be same distance to the original point in a four-dimension space. So when we see some points has the value in y dimension, in the w dimension, in this dimension, which means it also should have a shorter distance to this point. So So we change it to another angle to view the points. Maybe still too many points. So we change to this angle. So when we see from here, when it rotates back to the plane and then go to the negative direction of C and then go back to the plane, and it just rotates. When it's on this point, it's quite close to 0 point. So which means it also has a very large W value in a large absolute value in W direction. So which means when this number is multiplied by another quaternion number, it's rotating across around the 0 point. It's just rotating like this way, and it is not only rotating around the C axis, and it's rotating around the single point, and every value in every dimension, the values in all dimensions are changing with the value with the multiplication. So it's just in the plane of x and y, it's rotating in this way, and meanwhile it also rotates in C dimension, and it also rotates in W dimension. So just like a loop. So this is how it's rotating in a 4-dimensional space, the quaternion. Then we are going to so we try to understand how this is happening. How it's representing a 3D space rotating with 2 to 4-dimensional rotating. So let's go back to a very simple case where we only have one point in here. So this is a chosen case because the multiplier is very limited in this direction. It has only it uses only 0 values in x and y, and as I change w, and the c value will change to make sure the modulo is still 1, and the length of the vector. Maybe I'm calling it in the wrong word. So and as we change the value of I'm going to change this value to see how it's happening. So when w is 1, it means the scalar value of the vector is 1 and the rest parts should be 0. So it's placed in the 0 point in the 3D space, while it has a value in the w value, in w direction, and now I'm going to decrease the value 1 by 1, and so decrease a bit, and too much. 8, 9, 7, 6, 5, 3, 1, 1, 0, and 8. So it looks like it's rotating. If we change it to another direction to see how it's happening. let's do it again in 7, 7, 8, 7, 6, 7, 6, 7, 4, 7, 2, 7, 0. So it's just rotating as I change the this W. Meanwhile, while W is changing, C will still change along with this value. And since this when the length is always 1, and they consist circle here. Oh, somewhere else because it's the y is the z dimension and the w dimension, so it's invisible. It's invisible. You only get caught these two values. But it's a circle. It's truly a circle because it's the sum of the squares of these two numbers are still constant. Which means this circle consisted by w and c will control the rotation of this this multiplication. So now we have a way to create an angle of half theta and construct this factor. Anyway, at least we now have a solution to construct an angle. But also we have to notice that it's a very special case because the original point is on the xy plane. As we mentioned before, the multiplication turns the point force the point to rotate surround this point, surround the 0 point. So when it's in the plane, in the x1 plane where z is 0, it's rotating in the same plane. So it's just rotating. But what if the value of z is not 0? So I'm going to change it back to 0 and to 1, and now I'm going to add a point here to which has a positive value in the z direction, or even more points. I think 4 is enough. Maybe 4 is enough. Then I'm going to multiply again, and this time it's 2. Now it has more point here and point here. So this is shape when it multiplies. So using this seeing from this angle, well, you already see it. From this direction, it's still rotating. It's still just rotating. First, like we see before. But from this direction, we are seeing from x direction, the positive direction of x, and now these points are not only just rotating around the axis, and it's rotating around this point, even in 4 dimension, because here you find it's a value in 4D space. So this is the problem, because when it's rotating, it's also rotating in the 4th dimension, and it has to go really long steps before to go back to the original point. So so to construct another rotation to eliminate the value in w direction, and meanwhile to turn another angle, which is half theta, and we have need to construct another axis. Actually, I don't know very detailed about how this is, but from this equation, it's just an inverted value of the multiplier, and then multiplied in a reversed order. So sandwich. So which is this one. So if I change the value to be a larger value, no, or maybe smaller one. So it's very clear that when it's rotated, so it's rotating in this way. It's rotating. So from this angle, it's just a normal rotating. All the points are just rotating. Two points. Even with so both of them are rotating. We have to see it from very far. There's a perspective in 3.js camera, so yeah, we have to see quite far here to see still a rotation here, and even 8. Yeah. And also notice that there's this point which is not belong to the original multiplications, because this point is we made deliberately to construct our 3D rotation is here. And seen from this angle, it's very obvious that this point is rotated here. This point is rotated. We have to use another box to make it more visible. So this according to the plane, which is only 6 in the z direction, 6 in the direction, and these 2 points are in the same plane, and the internal point used to construct this rotation is here, and it's not in the same plane. And then when we see it from the plane, just like this. So these 2 angles are equal, and they are in the same. These 3 points are in the same plane. So this is the rotated position. So in conclusion, the constructed equation just rotated this point to here, which was previously going to rotate around this 0 point. So think I can modify the demo to hide some of the points. So here, okay, this is the demo. Oh, I would see it from this side. So this was the original version. Original version of an application when it's applied multiple times, like 8 times, or even more times. It's rotating around this point, but as we constructed this special access, now we have an like inverted or somehow contracted, or I don't know how to call it, but it's turning in this way, and it's turning back to this plane, same as the original point, and meanwhile it rotated in no, meanwhile it is rotated in a same direction, same angle as this point. Twice this angle. But meanwhile keep a so it has no value in w direction, and meanwhile it's in the meanwhile it's in the same plane. I think this demo is not explained very clearly, but you should get the idea from the graphs here. Sorry, thanks for watching.